Okay, this question asks us to determine the domain of the function f of x is log base 2 of x minus 5. And the thing to remember is the argument of a log function must be greater than 0. You cannot take the log of 0. You cannot take the log of a negative number. So if I want the domain of this function, the argument x minus 5 must be greater than 0. So x has to be greater than 5. If I do that in terms of a number line, open circle, 5 to infinity, round bracket 5 to infinity. Let's take a look at Desmos and see where Desmos goes with this. So I want to graph f of x equals log base 2. To get the base, to get a subscript, the underscore. So shift underscore after 0 to the left of plus, log base 2 of x minus 5. And let's take a look at that. Can you see that indeed that's our domain? We are never allowed to use 5. The function is getting very, very close to 5, but it never actually gets to 5. So the domain indeed does not include 5. It goes from 5 to infinity. The range, though, as long as we're looking at this, the range, it gets as low as you want and it gets as high as you want. It takes a long time growing, but it'll get there. So the range is all real numbers. The range is from negative infinity to positive infinity. The domain, again, as we said before, domain is from 5 to infinity. Let's determine the domain of the next one. So same issue. What is the domain of the following function? Log base 3 of x plus 4 over x plus 1. So if I'm looking at this, what am I thinking about? Well, the denominator cannot be 0. X plus 1 cannot be 0, so x cannot be negative 1. So I'm going to recognize that right away. The other issue is the argument of the log function must be greater than 0. So x plus 4 over x plus 1 must be greater than 0. Well, when does it equal 0? Well, when does x plus 4 over x plus 1 equal 0? Well, a fraction equals 0 if the numerator equals 0. So that will happen if x plus 4 is 0. That will happen if x is negative 4. So where is this thing greater than 0? We're saying negative 4 is where we're looking, is where we're starting. Well, I hope it's obvious. If I choose numbers to the right of negative 4, like negative 3, for example, negative 3 plus 4 is 1. Negative 3 plus 4 compared to negative 3 plus 1, what do we get? We get 1 over negative 2. So that's a problem. So what do we have to do here? How are we going to make sense of this? Well, remember we also eliminated negative 1. So we have negative 4 here. We have negative 1 here. We just tried negative 3. And we did not get something bigger than 0. When we plugged in negative 3, we had negative 1/2, not bigger than 0. So this is no. If we try something bigger than negative 1, for example, let's try 0. So again, we're plugging that into what? Into x plus 4. We're interested when is x plus 4 over x plus 1 bigger than 0. Plugging in 0, 0 plus 4 over 0 plus 1, is that bigger than 0? 4 is bigger than 0, that's yes. And how about to the left of -4, if I try -5 over here? Again, I want to see, is x plus 4 over x plus 1 bigger than 0? That's what we're interested in. So plug in -5 is -5 plus 4 over -5 plus 1. Is that bigger than 0? -5 plus 4 is -1. -5 plus 1 is -4. Is that bigger than 0? Is 1/4 bigger than 0? I think so. I think that's yes. So it looks like our domain for this thing is going to go from -infinity to -4, union from 1 to infinity. So let's take a look at Desmos and see if the graph gives us that. So back to Desmos. This is g of x. And it is log base 3 of x plus 4 over x plus 1. And what do you think? Do you see -infinity, -4, 1 to infinity? No. It's -1 to infinity. I have a little typo here. Let's fix it. All right, that's -1. Let's go ahead and change this to -1, which shows us why it's a good idea to go ahead and check your work. Let's go back to Desmos again and we can see it. There we go. So -1 to infinity is on the graph. -4 to -infinity, or -infinity to -4, reading left to right, is on the graph. So that graph of g of x, log base 3 of x plus 4 over x plus 1, looks an awful lot like we expected it to look when we said that our domain is -infinity to -4, union -1, of course, to infinity.